Over the last few months, the Arctic has been in the news quite a bit, primarily because the coverage of sea ice there decreased to its lowest on record back in September. Well, here in the meteorology department, we have our own Arctic explorer of sorts. He doesn't study sea ice, but he studies lots of other interesting processes going on in the Arctic. Dr. Jerry Harrington, and Jerry stops by tonight to join us on Weather World. Thanks for being here, Jerry.
Oh, thank you.
Now, somebody who happens to come across Jerry's website will notice right away that he has a thing for cold climates. There's links there to pictures from Alaska. How did that kind of interest develop?
Oh, I suppose that started when I was a kid. Grew up in the Midwest in Iowa and loved the winter, loved the cold. Actually, I think part of the reason why was because I had severe allergies to corn. And I just hated the summertime because,
Gotcha.
of course, the pollens were so bad.
Yeah.
It was just horrible. But the winter I loved. Developed a really strong interest in snow and snowflakes, and when I went to graduate school at Colorado State, I got to explore that more in my research as a graduate student, and as I became more and more interested in snow, just ended up with a natural interest in colder climates.
And that led you to the Arctic.
That led me to the Arctic.
And now some of your research focuses mainly on clouds, especially the layered ones, the ones we call stratus, and particularly when they have both water and ice in them, that interesting kind of hybrid cloud. What is it about that kind of cloud that's important?
Well, it's kind of interesting. I think one thing, first of all, that your viewers or many people probably don't know is that water drops don't freeze that easily, especially those that are made of pure liquid. I think we're all used to the fact that we go outside and we see puddles freeze very easily in the wintertime, and one of the things that we don't realize is that that's not pure water. It has stuff in it which helps to initiate the freezing process. Well, when we have pure water droplets, we can end up taking them down to really, really low temperatures, so without freezing them. So a lot of times water clouds, clouds in the wintertime will have a combination of both liquid and ice in them. And this actually happens quite frequently, temperatures down to maybe minus 20 or minus 30 degrees Celsius. So many of the clouds that people see that are producing snow actually have liquid in them. And the reason it's important is because that liquid is a strong source of vapor. Okay, which allows these ice crystals to grow to very, very big sizes, and of course that produces the beautiful snowflakes and the precipitation that we see.
So the ice crystals sort of steal liquid from the drops.
That's right.
And as in the form of the vapor.
Exactly,
Okay.
exactly.
Now you spent some time in the field in the Arctic. I think the project was called MPACE, Mixedphase Arctic Cloud Experiment.
That is right.
Tell us
That's
a little
correct.
bit about that experiment.
That was an interesting experiment. We went up to the North Slope of Alaska, which is basically the northern coast of Alaska, and we were looking at mixed phase clouds there in the winter, in the transition between summer to winter, which happens very rapidly in the Arctic. And the reason we were doing this was specifically to look at these clouds that have mixes of liquid and ice. Now the reason we were there is because in the Arctic, unlike in the mid-latitudes, you can end up with these clouds that have a lot of liquid water in them for a very long period of time. And we're not exactly sure why that's the case. So that's the reason why we were up there for the experiment.
Okay. Now, the Arctic has been kind of called the canary in the coal mine in terms of climate change, that any changes in the climate might show up fastest there. Has your work or work of others shown any detectable changes in the clouds over the Arctic? And if so, can that feed back into the mid-latitudes?
Well, that's an interesting question. We're not exactly sure at this stage. Part of the reason we were up there was to explore what might happen to the clouds, for example. So in a way, that's a little bit of an open question at present. Nobody's really sure what's happening to the clouds as, for example, you alluded to earlier, the sea ice is now starting to melt away very, very rapidly. In fact, I think in the last year we lost as much as we had lost in the previous 3 years.
Right.
It's an incredible drop. So we're not really sure what's happening to the clouds. Now, it could have, the thing is though, is it could have a very important effect on what happens here, because a lot of the mid-latitude weather that we have is driven by the fact that the equator is hot, the poles are cold, so if we change the temperature at the poles, of course that's going to change what happens in mid-latitude weather.
Right.
So even though at this stage we don't know exactly what's happening, it could be important for us here.
And I was checking some of the papers that you've worked on. You've worked on papers that had to deal with the effect of smoke and aerosols on clouds in the Amazon. I also saw you worked on a paper with supercell thunderstorms. So some of your work has to have broader applications.
Oh, that's definitely true. Even though I'm interested primarily in cold clouds and ice of all flavors and kinds, I'm also interested in clouds in the subtropics and the tropics. So we've done some work on those kind of clouds, and there what we've been primarily interested in is aerosol that get into the clouds and how they affect the precipitation process and the albedo, or how much solar radiation is reflected by the clouds.
Okay.
We're interested in this, of course, because that's also important for climate. Right? If we reflect more radiation back to space, of course, that's less that the Earth can absorb. Right. So I've worked on that. Plus, I've also worked on some things with supercell thunderstorms, looking at how the anvil that comes off of a thunderstorm, how that casts a shadow on the ground, which is cooler, and it turns out that this shadow may have important impacts on the life of the thunderstorm and how we forecast it.
Okay. Well, let's finish up. I just want folks to know Jerry teaches a class here, very popular, Applications of Computers to Meteorology, and all our Weather World viewers, they know that we're big into computers. We show computer models all the time, but that's not exactly what goes on in your class, is it?
No, not really. We don't teach students how to, say, develop a computer forecast model or any of those sorts of things. The class is a little bit different. As you know, meteorology is changing. A lot of the jobs that used to exist in meteorology were forecasting kind of jobs and so on and so forth. This class is a class that's designed to teach students, our undergraduates and graduate students if they want to take the class, how to use computers to do other kinds of things in meteorology. For example, data analysis, understanding how well a model forecast actually worked quantitatively. Okay. Many of these sorts of things really require a very, very strong ability with respect to using computers nowadays than it did in the past. So that's kind of the idea behind the course, is to train our students in that.
All right. Dr. Jerry Harrington, Department of Meteorology, thanks for stopping by,
Oh,
Jerry.
no problem. My pleasure.
We'll be back in a moment with a recap of the short-range forecast.